The National Electrical Code does not explicitly prohibit running cooling water tubing or hose in the same cable tray as 480 volts conductors, provided they are separated by a metal partition. However, several precautions are necessary to ensure safety and code compliance. Firstly, the metal partition must be of adequate thickness and construction to provide a reliable barrier between the cooling water tubing or hose and the 480 volts conductors. This thickness should be sufficient to prevent any accidental contact, considering factors like vibration, movement, or potential damage to the tubing or conductors. The partition needs to maintain its integrity over time and under various environmental conditions. Secondly, the cooling water tubing or hose must be securely fastened to the metal partition. This is crucial to prevent any movement or displacement of the tubing that could lead to contact with the energized conductors. The fastening method should be robust and resistant to loosening due to vibration, temperature changes, or other mechanical stresses. Consider using clamps, brackets, or other suitable hardware that are specifically designed for securing tubing or hoses in industrial environments. The chosen fastening method should also be compatible with the materials of both the tubing and the partition to prevent corrosion or other forms of degradation. Thirdly, the metal partition must be properly grounded. Grounding the partition ensures that any fault current resulting from accidental contact between the 480 volts conductors and the partition will be safely conducted to ground, minimizing the risk of electric shock. The grounding connection should be made in accordance with National Electrical Code Article 250, which provides detailed requirements for grounding and bonding electrical systems. Use a grounding conductor of appropriate size and material, and ensure that the connection is mechanically secure and electrically conductive. The grounding conductor should be connected to a suitable grounding electrode system, such as a ground rod, grounding ring, or metal water pipe. In addition to these precautions, it is important to consider the overall weight and loading of the cable tray. The combined weight of the conductors, tubing, partition, and any other equipment installed in the tray must not exceed the manufacturer's load rating. Overloading a cable tray can compromise its structural integrity and potentially lead to collapse, creating a safety hazard. Consult the cable tray manufacturer's specifications to determine the allowable load rating and ensure that the installation complies with these requirements. Furthermore, carefully inspect the cooling water tubing or hose for any signs of damage or degradation before installation. Look for cracks, abrasions, or other defects that could compromise its integrity and lead to leaks. Use tubing or hose that is specifically designed for the intended application and that is compatible with the cooling fluid being used. Consider the temperature and pressure ratio of the tubing or hose to ensure that it can withstand the operating conditions of the cooling system. Regularly inspect the tubing or hose for any signs of wear or damage and replace it as needed. Also, ensure that all electrical connections are properly made and that all conductors are adequately insulated. Use properly rated connectors and terminations, and follow the manufacturer's instructions for installation. Inspect the insulation of the conductors for any signs of damage or degradation and replace any damaged conductors. The National Electrical Code provides detailed requirements for conductor insulation and protection in Article 310. Before working on any electrical equipment, always de-energize the circuit and verify that it is de-energized using a properly rated voltage tester. Follow all applicable safety procedures and use appropriate personal protective equipment such as gloves, safety glasses, and insulated tools. Be aware of the potential hazards associated with working with electricity and take steps to minimize the risks. If you are not qualified to work on electrical equipment, hire a licensed electrician to perform the work. The National Electrical Code is a comprehensive set of standards for the safe installation of electrical wiring and equipment. It is important to consult the latest edition of the National Electrical Code and to comply with all applicable requirements. The National Electrical Code is updated every 3 years, so it is important to stay current with the latest changes. Also, consider the specific requirements of the local jurisdiction where the installation is being performed. Local codes may have additional requirements that are not covered in the National Electrical Code. It is important to consult with the local electrical inspector to ensure that the installation complies with all applicable codes and regulations. Furthermore, ensure proper labeling and identification of all conductors, tubing, and equipment installed in the cable tray. Use clear and durable labels that are resistant to fading or deterioration. The label should identify the voltage of the conductors, the type of fluid in the tubing, and the function of the equipment. Proper labeling and identification can help to prevent accidents and make it easier to troubleshoot problems in the future. Additionally, consider the potential for corrosion or other forms of environmental degradation. If the cable tray is located in a corrosive environment, use materials that are resistant to corrosion, such as stainless steel or aluminum. Protect the conductors and tubing from exposure to moisture, chemicals, or other corrosive substances. Regularly inspect the cable tray and its components for any signs of corrosion and take steps to prevent or mitigate the effects of corrosion. Finally, remember that the information provided here is for general guidance only and should not be considered a substitute for professional engineering advice. Always consult with a qualified engineer or electrical contractor to ensure that the installation is safe and complies with all applicable codes and regulations. They can assess the specific conditions of the installation and provide recommendations for the appropriate materials, methods, and procedures. A thorough understanding of electrical safety principles and the National Electrical Code is essential for anyone working with electrical equipment. Continuous learning and professional development are important for staying up to date with the latest codes, standards, and best practices. By following these precautions and consulting with qualified professionals, it is possible to safely run cooling water tubing or hose in the same cable tray as 480 volts conductors, provided they are separated by a metal partition. It is important to prioritize safety and to comply with all applicable codes and regulations to protect people and property from electrical hazards. Also, remember to consider future maintenance and modifications when designing and installing cable tray systems. Provide adequate access to all components for inspection, testing, and repair. Ensure that there is sufficient space to add or remove conductors or tubing as needed. Consider the potential for future changes in a load requirements and design the system to accommodate these changes. A well-designed and properly installed cable tray system can provide a safe and reliable means of supporting and protecting electrical wiring and equipment. It is important to take the time to plan and execute the installation carefully and to follow all applicable codes and regulations. Remember, safety is always the top priority when working with electricity. In addition to the above considerations, ensure the cable tray is installed according to the manufacturer's instructions. Improper installation can compromise the structural integrity and load-bearing capacity of the tray. Use appropriate supports and fasteners, and space them according to the manufacturer's recommendations. Also, make sure the cable tray is properly aligned and level to prevent undue stress on the conductors and tubing. Consider the ambient temperature and humidity when selecting materials and designing the cable tray system. Extreme temperatures or high humidity can affect the performance and lifespan of the conductors, tubing, and other components. Choose materials that are suitable for the operating environment and take steps to protect the system from these environmental factors. Regularly inspect the cable tray system for any signs of damage, wear, or corrosion. Perform routine maintenance, such as tightening fasteners, cleaning surfaces, and replacing damaged components. Keep the cable tray system free of debris and obstructions to ensure proper ventilation and prevent overheating. Document all aspects of the cable tray installation, including the materials used, the installation methods, and the test results. Maintain accurate records of all maintenance and repairs performed on the system. This documentation can be valuable for troubleshooting problems and planning future modifications. When making any changes or modifications to the cable tray system, be sure to follow all applicable codes and regulations. Consult with a qualified engineer or electrical contractor to ensure that the changes are safe and compliant. Do not make any unauthorized modifications to the system, as this could compromise its safety and reliability. Also, consider the potential for electromagnetic interference. If sensitive electronic equipment is located near the cable tray, take steps to minimize the risk of electromagnetic interference. Use shielded conductors and grounding techniques to reduce the level of interference. Consult with an expert in electromagnetic compatibility to ensure that the system meets all applicable requirements. Furthermore, ensure that all personnel working on or near the cable tray system are properly trained in electrical safety. Provide regular training on the hazards of electricity, the proper use of personal protective equipment, and the safe work practices to follow. Emphasize the importance of following all applicable codes and regulations. By taking these additional precautions, you can further enhance the safety and reliability of the cable tray system. Remember, a well-designed, properly installed, and regularly maintained cable tray system is essential for ensuring the safe and efficient distribution of electrical power. Finally, let's discuss some specific National Electrical Code articles that are relevant to this topic. National Electrical Code Article 318 covers cable trays, including their construction, installation, and use. It provides requirements for the types of cables that are permitted to be installed in cable trays, the spacing of cables, and the support of cable trays. National Electrical Code Article 300 covers general wiring methods, including requirements for the protection of conductors, the grounding of electrical systems, and the installation of electrical equipment. National Electrical Code Article 250 covers grounding and bonding, including requirements for the grounding of electrical systems, the bonding of metal parts, and the use of grounding electrodes. National Electrical Code Article 310 covers conductors for general wiring, including requirements for conductor insulation, opacity, and installation. These articles provide detailed guidance on how to safely and effectively install and maintain electrical wiring and equipment. It is important to consult these articles and to comply with all applicable requirements. In addition to these National Electrical Code articles, there may be other codes and standards that are relevant to the installation of cable trays and electrical wiring. These may include local codes, industry standards, and manufacturer specifications. It is important to be familiar with all applicable codes and standards and to comply with their requirements. By following these guidelines, you can ensure that the installation of cooling water tubing or hose in the same cable tray as 480 volts conductors is done safely and in accordance with all applicable codes and regulations. Remember, safety is always the top priority when working with electricity. Take the time to plan and execute the installation carefully and consult with qualified professionals as needed. A well-designed and properly installed cable tray system can provide a safe and reliable means of supporting and protecting electrical wiring and equipment for many years to come. Always remember to de-energize the circuit before working on any electrical equipment and use appropriate personal protective equipment. Be aware of the potential hazards associated with working with electricity and take steps to minimize the risks. If you are not qualified to work on electrical equipment, hire a licensed electrician to perform the work. Electrical safety is everyone's responsibility. By working together to follow safe work practices and comply with all applicable codes and regulations, we can prevent accidents and protect people and property from electrical hazards. Also, keep in mind that the specific requirements for installing cooling water tubing or hose in the same cable tray as 480 volts conductors may vary depending on the application and the specific equipment being used. It is important to consult with the equipment manufacturer and to follow their recommendations for installation. The manufacturer may have specific requirements for the spacing of conductors, the grounding of equipment, and the protection of wiring. By following the manufacturer's recommendations, you can ensure that the installation is safe and that the equipment will operate reliably. Furthermore, consider the potential for future expansion or modifications when designing the cable tray system. Provide sufficient space for adding new conductors or tubing as needed. Design the system to accommodate future changes in the load requirements. A well-designed cable tray system should be flexible and adaptable to changing needs. Finally, remember that the information provided here is for general guidance only and should not be considered a substitute for professional engineering advice. Always consult with a qualified engineer or electrical contractor to ensure that the installation is safe and complies with all applicable codes and regulations. They can assess the specific conditions of the installation and provide recommendations for the appropriate materials, methods, and procedures.